Right. Okay, Lamai, let's start the discussion. Right. Lamai, you read the problem. Let k greater than 1. K greater than 1, given fact. K is greater than 1. Show that the equation x square minus, I will write the equation x square minus 2 times k plus 1 x plus k minus 3 square equals 0 has real distinct roots. Right, Lamai? Lamai, should I remind you to turn on your camera? Right? Should I do so? Right? You are math students, right? The people who are doing mathematics cannot forget something, no? Right? Why are you like this? Right? Hurry up. Come on. Go. Right? Please add Kulini. Kulini has come now. Aranyo, Chandalio, Avandi can do this. You can add the participants who are waiting in the waiting room. Right? Okay, then don't wait until I tell them, you can add them. Okay, right. Yes, you have to use a separate book, right? If there's any question, please ask. Don't send me text, right? It's difficult to read. Okay, Lamai, let's see this one, right? X square minus 2, k plus 1, x, k minus 3 square equals 0 has real distinct roots. Okay, the condition given is only k is greater than 1, right? Okay, within this k is greater than 1, then we have to tell the real distinct roots. To prove that real distinct roots, then always the delta x is the theory. The delta x, if the delta x, so what's the delta x? B square minus 4ac. You can check whether this becoming positive number. If the delta x is theory, then you better remind the theory part. If delta x is positive, right, real and distinct, right? The delta x is 0. Delta x is 0. Real but not distinct. But what is the coincident? Coincident. Delta x is 0. Coincident. Same rules. Right? Wait. You can remember this. And delta x negative. This should be right imaginary roots, not real roots. These are the main three concepts. But without distinct cases, then we can write down if the roots are real only. We can write down delta x can be greater than or equal 0 because they always real. We don't know whether they are distinct or something else, rational or irrational. We don't find. Especially if you want to find out that whether the roots are rational or irrational, you know that to have rational roots, the delta x should be positive always. That is a constant, but not only positive, should have a perfect score. You know that. That is an additional case. For exam papers, they don't ask that mainly. This is the main three parts that you want to answer, right? Real and distinct, and what? Coincident and not real. These are the cases, right? Okay. Now we have to show that what real distinct roots. Okay, let's check this. B minus 2 k plus 1 and square minus 4 ac is 1. C is k minus 3 square. Right? And we better simplify this. Now my minus 2, square of the minus 2 plus 4. And there is k plus 1 square. And minus 4. This is k minus 3 square. Right? Then we better make this 4 as a factor because 4 is a factor. You better take it out, right? Therefore, then what is remaining? K plus 1 minus k minus 3 And we can further write what? K plus 1 plus K minus 3. What did I do here? What's the concept I applied together? Right? Because of having between K is a factor, now you can see difference of two squares. Then I just applied that, or otherwise you should have got the binomial expansion. Doesn't matter, right? Whatever. Then you can simplify. Inside the bracket, your answers are coming. Okay, get it? So what's happening? We can take a positive answer. Right now, therefore, K and minus K going to cancel. Right inside this, K and minus K going to cancel. 1 and minus plus 3. Then inside the first bracket, right? 1 and plus 3 remaining, and other bracket, what's happened? K and K, 2K, and my plus 1 minus 3 minus 2. Right? Okay, now what's going to be? What's your answer? K, and this is being 4, and there is another 4 also, and you can further have 2 as a factor, K minus 1. Right? This answer is the 4, and you can get the 2 as a factor. It's 32 K minus 1. 32 K minus 1. Okay, now tell me what's happening. Because in the beginning, K is greater than 1. Right? As K is greater than 1, what's happening? We can further write it. It's positive. Right? As K greater than 1, 32 K minus 1, right? Positive. Therefore, delta x positive. Roots are real distinct. Roots are real distinct. Write down. Roots are real distinct. But what is experiencing the problems that you have faced before this? Right? A lot of times, how you have come to the steps like that, you must show that the roots are real and distinct. In a lot of problems you have faced, mainly you are getting square part, right? Without that inequality type. You can remember, if you have done homework successfully, can you remember? In a lot of problems there you are getting perfect square parts and addition parts and other square parts to get a positive cases. Can you remember? But this time, then by giving the inequality, right, then you have to logically find out that connection being positive or otherwise negative, but this time we want to find the positiveness, right? Okay, now that's what at the exam, then you had, right, expect how they like, not you, how you like, right? How you like is not implementing, how they like is your answer, right? Your answer must be according to that. Okay, now let's see the next part of the problem. The same problem, right? There are several cases, right? In addition to this, right, we now did this part, right? And we have to further do, let alpha and beta be these roots. These roots are alpha and beta. Write down alpha plus beta in terms of alpha plus beta in terms of k. Right? So one question, and find the values of k such that both alpha and beta are positive. Okay, we will discuss that case later. The before that we can write down what alpha plus beta and alpha beta together, right? Okay. We will write it. Come on. And if I erase this, You can write alpha plus beta because of minus b over a. You know, minus b minus 2k plus 1 over a is 1. So what's the answer? 2k plus 1. Right? I have written from the beginning, but no need to write everything. I don't expect that students will write minus b over a even. No need to write them. Right? Then actually you can find this 2 times k plus 1. If you have a lot of confidence, you can write without mentioning the minus plus also. Right? It doesn't matter. This is not all elements, this is k elements. That's right. Okay. Right now you can go for the product of the two roots. What is that? A plus b, alpha plus beta, and alpha beta. Alpha beta, c by a. Theoretically, we know that c by a. The c is there. It's a perfect square terms in terms of k. This is the c. Right? By a, you know, is 1. Therefore, we can write down this answer. Right? These are two answers. Because of that, you can underline. Right? Two answers that they expect. You can underline. Right? And finally, so what is the case they asked, right? Then we wrote it, and what is this special case? In our theory classes, even right for all over A-level 2023, I haven't discussed this part. This is the sign of the roots. Sign of the roots, Raman. Okay, let's see. What is this? And find the value of k such that both alpha and beta are positive. Such that both alpha and beta are positive. I mean, what do you mean by alpha and beta? You know, what do you mean by alpha and beta? That is the concept, right? If you identify what alpha and beta, then we can talk about positiveness, negativeness. It doesn't matter, right? Alpha and beta are the two roots. You imagine for practical problems, for any quadratic equation, the two roots can be positive. Sometimes two roots can be negative. Sometimes one can be negative and one can be positive. Right? One can be zero and sometimes negative or positive. Right? Everything can be happen. Sometimes the roots can be imaginary, but this instance roots are real. Right? Okay. Whatever the roots are, then if the roots are positive, that's the case, right? And find the values of k. Right? We have to find the values of k. Right? Then read this. Find the value of k. Then value of k, or is it values of k? Then I also highlight this. Is it value of k or values of k? Values of k. The values of k means, is there one value or several values? Right? Are there one value or several values? There should be several values. Lamai, please be with your camera turning on. Okay, I don't ask you, right? I don't like to insist every time. Please, right? Then don't go to waste my time, right? Okay, see this. Values of k, right? You can comment, right? Values of k means is a one value or several values. There can be several values. Several values means it can be an inequality. Values of k, you must right carefully read it. Value of k, not values of k, right? Therefore, values of k such that both alpha and beta are positive. Then you can accompany what alpha and beta roots. Okay, in a practical purpose, if I remind you some two roots like you imagine 2 and 5, positive, minus 2 and plus 3, one is negative, other is positive, like that. Okay, two roots can be like this, alpha and beta. But by means of alpha beta, what we have earlier written now, sum of the two roots and product of the two roots. Can you see this? Sum of the two roots and product of the roots. The by means of a sum as well as a product, then you must think a little bit more than what you see. How to get a positive connection? If the two roots are positive, there should be alpha positive, beta positive, right? Then what happened? The sum of the roots what will remain? If alpha positive, beta positive, right? What will happen on alpha plus beta? We must discuss this. What will happen on alpha plus beta? Then What is alpha plus beta? Alpha plus beta positive. Alpha plus beta must be positive. By means of this connection, we can have an inequality to write down the values of k. And not only that, product alpha beta. If they are positive, right, then mathematically I will write that. Okay, if alpha positive, if beta positive, then what will happen to alpha beta should be also positive. But we cannot get this kind reason. The product can be positive even when the two roots are negative even. You know that negative roots minus minus become, if the alpha is -3, if the beta is -2, the what will happen? Negative getting positive results coming. Therefore, we cannot consider this case. Right? By means of this case, we cannot realize. Therefore, then we have to come to this. If the two roots are positive, the sum of the two roots can be positive. Therefore, this is inequality. Right? Then mathematically, I can write down how if alpha positive, beta positive, then alpha plus beta is positive. Now, what is the alpha plus beta that we have got here? It is therefore you can upload below alpha plus beta what we have written right over there. You know, 2 times k plus 1 is the case. Now, what's happening? You can write down, right, k plus 1 greater than 0 because we can divide both sides by 2. And what is the result coming? K greater than -1. K greater than -1. At the beginning itself, there is a given inequality supplied. What was that inequality? Everything is depend on that K consider, right? Because we have to consider that. So what is that K? K greater than 1. And this instance we are getting K greater than -1. By means of these two inequalities, what should we get? Right, sub that two roots are positive, right? Then sometimes you will write k greater than -1, right? Due to the k is greater than +1, right? Then we have to consider, right? Also, look at this. Wait. K greater than +1 given. But if I mark two values on a number line, what's happening? This is the result coming k greater than 1. This is a given one, k greater than +1. Therefore, your values are k greater than 1. Right? We have to consider the intersection of the right all conditions. Right? These are the values of k greater than 1. Right? Now, by writing this, but I don't think that new students and some students who are doing maths, right? I don't think that they have a lot of confidence, right? They will accept, yes, correct, no, because alpha positive, beta positive, should be positive. But just because of we have k greater than 1, the unfit answer has come my way, right? You don't believe on that, right? Unfit, little bit, right? Okay, we will just check, right, backwards whether k greater than 1 is right matching with them. Then we can check. Right, if k greater than 1, what should be happen? The two roots should be positive. That means alpha plus beta should be positive. The sum of the two roots should be positive. Okay, Laman? Okay, you are writing. Relevant. Back up to the top of the question again. Because we had to conduct trigonometry problem also. Right. Okay. Now, okay, this is a little bit additional case, right? Then we can later find the final question. Let k between 1 and 3 and find the quadratic equation of roots are 1 over root alpha 1 over root beta. We can find inverse of k. Right. But before that, can you make confidence on the answer that we got k greater than 1? Right. If the k is greater than 1, what are the possible values that k can take? 2, 3, 4, 5, 6. No? Right. Okay. Then if you substitute the values to 2, 3, 4, 5 onwards, then your two roots alpha beta should be whatever the two roots should be always be positive, right? That should be happen, right? Then if you just check them, then this is something additional, right? Not belong to the discussion, no need to write them, right? But you can check, right? If you have that, okay. Then if I erase this case. Right, I'll keep this. Right. Now what will happen? Okay, let's see this. This is the equation x square minus 2 times k plus 1. This is additional, no need to write down because, right, your confidence, right, square equals 0. This is the equation. Right, for this equation, if I substitute a value like k greater than 1, k greater than 1.7, then if we just substitute 2 here, when k is 2, this is for your confidence, x square minus 2, then 2 plus 1, what is that? 3. 2 times 3, what is the whole answer? Then I will write down together now, because I know what is that? 6, and there was x later, 6x. And if you write down 2 here, 2 minus 3, 2 minus 3, 1 to the power 1. Right? The what's happening? Right. Now to solve this, right, then we can find factors. But however, we must check whether the two roots positive. We can find it, right? Then if we use it complete squares, we can solve it. X minus 3 square, then minus 9 plus 1 equal 0. X minus 3, right, square equal 8. Right? And what's happening? X equal 3 plus or minus root 8. Now, you know, x equal 3 plus or minus 2 root 2, know that because 4 times 2 is coming for instead of the root 8. This is 3 minus 2 root 2 or 3 plus 2 root 2. Alpha is 3 minus 2 root 2, beta is 3 plus 2 root 2. Like that, you can consider. Right? The already this beta is positive. We have to check this is positive. Right? 2 root 2. You can just calculate using a calculator or something. Otherwise, then if you have a rough idea regarding this, it is 1.4. 1.4 means 3 minus 2.8. Now check whether it's positive or negative. Because of 0.2 comes and beta is, right, 3 plus 2 root 2. This is always positive, no? Right? Then alpha positive, beta positive, right? Both roots are positive. Right? Right? If you want to learn furthermore, that this is the point I make you on behalf of your confidence, right? This is something little bit additional, right? Then you will check onwards, right? And also you can keep greater than 1. No? What will happen when k is 1? What will happen when k is 0? Right? You will check. Right? Now you won't get two distinct roots which has become a positive. Right? Two distinct roots will have, right? But both cannot be positive. Sometimes one can be 0. Is 0 positive? 0, 0 is not positive. If you get 0, don't get this root as a positive root, it's wrong now. Right? 0 is right, neither positive nor negative. Right? Okay, you better do this practical, right? In the discussion. After the complete discussion, please do this, right, to make your whole confidence. Right? Okay. Now we can go towards the next part, final part of the part A. Right? See. Now let case between 1 and 3. In the case between 1 and 3, case between 1 and 3 means both roots are right positive in consideration positive. It doesn't matter. Find the quadratic equation whose roots are 1 over root alpha, 1 over root beta. By giving this, what do you mean by that? Alpha is positive, beta is positive, right? You know that, right? That is what given. Therefore, this is existing in the world. But if alpha is a negative value here, if the case lies between 1 and without 1 and 3, right? More than 1, right? Then this sometimes can have been negative. Can I write down a negative value? Right? No need to consider for your answer sheet. I am just explaining. Right? If this being an alpha is being a negative 3 or something, alpha will negative uttaraya kaavana වැරදිලා hari. Square root එකක් තියෙන එකක්. Rational, irrational කියලා ගන්න බෑ. මේක මොකක්ද? Complex number එකක්. ඒක complex roots එක හරියන්නේ. අපිට තියෙන rational නියම roots තියෙනවා. right? ඒ නිසායි ඒක දාලා තියෙන්නේ. අපිට ඒකට අලුතෙන් දෙයක් අමුතුවෙන් ලියන්න අවශ්‍ය නැහැ. right? මේක අපිට හදන්න කියලා නෑ ලේට්. so okay. ඒක අපි තේරුම් ගන්න විදිහ බලන්න දෙලා තියෙනවා. right. okay. Find the quadratic equation whose roots are 1 over root alpha and 1 over root beta in terms of k. Okay. To find the quadratic equation whose roots are right 1 over alpha and 1 over beta in terms of k, then we have to do it. Okay. Now I'll come to right this place over there, right? We don't know this one furthermore, right? Okay, now. Okay, let's see. Right. Now, sum of the roots. Sum of roots. You can find 1 over root alpha, 1 over root beta. Please find the sum of the roots. And find the product of the roots. And you make the quadratic equation whose roots are there. But alpha plus beta, alpha beta product are also there. Then you better always write down any direction given in terms of sum of the alpha beta and product of the alpha beta. Okay. Now still we cannot have a summation. Therefore, you can write down the product alpha beta and root beta plus root alpha. In this way it's coming. Okay. Right. Now, you know, for this root alpha beta, it doesn't matter. We can just substitute what alpha beta is k minus 3. You know it. We can write below that k minus 3 is. But this is a doubt still you have, right? Root alpha plus root beta. Then what's the method that you have to follow to get rid from this square rootness? Then you know, then instead of this one, you must write root alpha plus root beta, right? The square and square root. You know it. And you have to further simplify and have it. And that's how you are getting some of the roots. And you must further find product of the roots of 1 over alpha, 1 over beta within roots. And you can next generate the quadratic equation that they expect. Okay, come on, Lamai. You can do it alone. Okay. Now what's happening? It's alpha plus beta. 2 times alpha beta square root and square root over k minus 3. And step, you know, square root getting cancelled. Right. And further I did. Right. The sum of the two roots, you know, sum of the two roots, we have got, right, 2 times k plus 1. You will write down it. 2 times k plus 1. 2 times k plus 1. This is the sum. And plus 2 root alpha beta is k minus 3 square over k minus 3. So once you answer, again you can cancel square root. It's 2k plus 2, 2k minus 6 square root, but k minus 3. What's the simplification? It's 4k minus 4. 4k minus 4, k minus 3, but there's. In that case, then you can write 2. You can make 4 as a factor, but you can take it outside from the square root. It will be 2 because of the square root. You can operate it 2 out when you come to outside, right? 2, but k minus 1 still inside square root, right? And this is k minus 3. This is the sum of the two roots, and now you can find the product of the two roots. Then you can generate the equation, right? The product of the two roots. Then you write product. The sum is okay. Now you will write product of the two roots. Product 1 over root alpha 1 over root beta. It's 1 over alpha beta. 1 over alpha beta. Now alpha beta, you know, again this product is k minus 3. Sorry. Right? K minus 3. Whole thing is square. It is 1 over k minus 3. This is the product. 1 over k minus 3. Now product is okay. 1 over k minus 3. Right? And you can remember sum is okay. Right? Sum is this. The product is this. Therefore, you can write down the right equation. Equation. Right now. Therefore, equation. Right. X square minus sum of roots x plus product equals 0. Okay, write down it. X square minus the sum of the two roots 2 times k minus 1 over k minus 3 plus product of 1 over k minus 3. To complete the answer, you have to multiply this by k minus 3. Therefore, what is your answer going to be? Right, your answer is k minus 3 x square minus, right? This is x is coming here, right? Sorry, yeah, x is there. 2 times k minus 1, x is there, plus 1 equals 0. This is the answer. Right, Lavan? That inequality case between 1 and 3 shouldn't be proved because they have given us late. Therefore, no need to prove again and again. Right? Then we can use if we want or otherwise, then you can logically, right, think about the things given. Okay, now we can go to the part B. Part B. Right. Now, let fx equal 2x cubed ax square plus bx plus 1, and we must write it now. This is fx, we want it. Fx 2x cubed plus ax square bx plus 1. And gx, we can write it. Gx equal x cubed plus cx square plus ax plus 1, where a, b, c right members of real numbers. It is given that the remainder when fx is divided by x minus 1. X minus 1 is the linear division, right? Due to a linear division, right? Now we can apply the remainder theorem because of linear division, right? Then x minus 1, the remainder is 5. The remainder is 5. The remainder is 5. Therefore, then by dividing by x minus 1, you can write down. Therefore, f1 is 5. Right? If we don't apply the algorithm, then directly we can write down f1 is 5. Then 5 marks will be given for this. Right? But when you are answering, I saw in some answers, right, they have written this whole equation equal to x minus 1 times 5x plus, right, something like x minus 1, equal plus 5, right? It is not necessary, right? Then later we can substitute x equal 1 and you can find the answer also, but no need. Then this is theoretical, then theoretically we can apply here. F1 is 5 because once you have seen, right? If you remember, the remainder is given like 5, 6, then you will write down the 0 value of the bracket, then 0 value of x minus 1 is 1, therefore f1 is 5. Otherwise, we can properly write when divided by x minus 1 something, right? Okay. Okay, now f1, you know, therefore we can write down lamai 2 times 1 to the power 3, a times 1 square, b times 1 plus 1 equal 5. Right? Then a plus b, this is 2 and this is 1. 2 and 1, 3. When you subtract 3 from the 5, this is 2. No need to solve your steps like all level students. This is advanced level. Write down your answer as how you fail. This is the connection number 1 you got over there. And what is the connection given? And that the remainder when gx is divided by, my goodness, what is that? Gx is divided by, now it's a quadratic equation, quadratic expression, x square plus x minus 2. X squared plus x minus 2, it's a quadratic. And remainder is also x plus 1, linear one. Yes. Find the values of a, b, c. This time, can we apply the remainder theorem as previous? Never, never. This time we have to write down the whole algorithm, right? Then we must write down that gx, right? You know the x cube cx square plus ax plus 1. Can you see this? Let us see something. Equal to, right? You know the x square plus x minus 2 times 5x, right? Plus x plus 2. This is the whole algorithm. X plus 1, no? X plus 1. X plus 1 log. This must be the whole algorithm that a student must write. To find the ABC, A and C connection, right? Then you must have factors, right? Or otherwise constant equations. But this time for x we don't know. Therefore, definitely must have factors. We must further write down the factors belong to this, and we can next find out the values right now. Then what are the factors belong to x square plus x minus 2? It's written xx and 2 and 1 plus and minus. Right? Then we can substitute x equal 1 for the both side, x equal minus 2 for the both side, and we can get the values of a and c. Next, we can find the value of b in the equation 1. Right? When x equal, this is not partial fraction. In partial fraction, we don't go to substitute directly, but in equation we can write substitution. When x equals the 1, what's happening? It's 1 cube c1 square a times 1 plus 1 equal, this being 0, 0 plus 1 plus 1. So what is the connection for a plus c? You know, a plus c equal to 0. A equal minus c. How did I get a plus c 0? Because I didn't show my steps. Yes, because 1 and 1 getting 2, and right hand side also they have 2. Then we can just cancel them. Right? No need to write down because we are not O levels. We are in now advanced level class, right? A equal minus c. Okay, now when x equal, what is the zero value of the x plus 2? Now my zero value of x plus 2 minus 2. Therefore, x equal minus 2 we have substitute. And minus 2 to the power 3, c times minus 2 square, a times minus 2 plus 1 equal 0 times, this whole expression becomes 0, you know, and 2 plus minus 2 plus 1. We got minus 2 minus 2 plus 1. And your answer is going to be, this is 4c minus 2a. I think this is minus 8 and this plus 1. It will be minus 7. And there is minus 1 will be plus 6. Listen here, minus 8 and this plus 1 minus 7. We have to get to the other side, plus 7 and this one plus 8. We will subtract minus 2 plus 6. Right? Because of a equal minus c, instead of a you will write down minus c there. Then OC, right, minus 2 minus c. Right? Then you can, how you feel is okay, right? Then minus 1 is getting plus 1, then 6c equals 6, then c equal 1, c equal 1. C equal 1, then without steps, right, we can write c equal 1. C equal 1. If c equal 1, what is a? Therefore, a equal minus 1. If a equal minus 1 into 1, in 1, minus 1 plus b equal to a equal 3. Right? A is minus 1, it starts with the negative value, a, b, c, a is minus 1, b is 3, and c is plus 1. Now we got the a, b, c values. Okay, now we have done this question until this ABC values. Right? It's perfectly okay. Right? This is okay. Right now, let's see. Now, with these values for A, B, C, A equal -1, B equal 3, and C equal 1. Show that fx minus 2gx less than or equal 13/12. Okay. How to do this? Right. See. Right. Now, what is that? Gx minus. Is it gx minus? Gx minus or fx minus? Fx minus 2gx. Right. Let's see. Fx. Right. Fx minus 2gx. 13/12 or something there. Like that. This was your target. Lamai, the problem is you are not thinking. With the values of A, B, C, can't you find out fx? Listen me here. Can't you find out fx as a correct function? We can find it. Can't you find out gx? You can find it. Can't you subtract fx and 2 times the gx? We can subtract. We can find another function like polynomial function like x cube plus bx power or bx power plus ax power plus. Right? I don't mind. Right? Right? I again should remember Sanuji, Hiruna, Maliti, right? Chatuni, Shenali. What are you doing? Right? Mario, Judith, Sineja. Right? You can't understand this. Right? Camera on karanda. Right? Okay. Right? What are we talking about this? Right? Fx minus 2gx less than or equal 13/12. Okay, Lamai, before we go to this, we have to go for a basic concept of the mathematics, right? Through your O-levels, right? Lamai, then if I write down like this, series in age, right? Okay. Series in okay. Okay. So how can you read this as a sentence? That's what I want to go to this before you understand this. What is a real sentence of this?
Series age is greater than or equal to 90.
The same, no. I want this into words, but with the real words, right? We can read the mathematical expression like greater than or less, more than greater than or less than or equal. There's a definition. What is that? That is what that lot of students don't do this. They cannot. How can they start the initial step? If you understand this one, you will definitely start this. What's the meaning?
Series is positive. Positive.
To tell positive or negative, follow. This should be happening with 0 positive or negative. Can't be negative or positive negative. No. I'm not talking about that. What is this? That's the point. O-levels. I don't know that. In O-levels, your teachers have taught that, but O-levels. Not around 90. Stupid. My blood is stupid, right? Look at this. This is how you have to read this sentence, right? The maximum age of series A. Maximum age of series A is 90 years. What would I have your talk now? We got it better, people. Series A नारे गोटा आ गए मरका बनने मौका हुआ ओ कोई का ये एज के लिए नोना एज के लिए मेरा तमको देखो गोटा भी है मैं मौका भी कहते हैं राइट एज के लिए कोई भी किया गोटा भी एज में आता दी पन सॉरी 90 के लिए दी पन डैम को हम देखियो maximum
Minimum age.
minimum right the गोटा भी minimum age is 90 माला हम लोग के ना वो अनुवाद नहीं है दिया होते हैं අඩුම අනුව ජීවත් වෙනවලු right එපානේ දාලා අපි ඒක කතා නොකරමු right ළමයි නේද දැන් මේ තත්ත්වය හැටියට අපි සුවිතේ ගිහින් බයිනවා ඉතින් ඊට කලින් හොඳ කිව්වා ඉතින් මේක ඉතින් දේවල් තියෙනවා ආයි ඉතින් දෙකත් මාරු වෙන්නත් පුළුවන් ඒ නිසා කතා කරමු right ළමයි මෙතනදී yes the maximum age of citizen is 90 කියලා concept එක එනම් මේකේ වැලියු කියලා මේක කියවන්න දැන් mathematically yes let's read this the maximum value of fx minus 2gx is 13/20 just write down this to be sentence otherwise how can you identify this the maximum value of fx minus 2gx is 13/12 to have a maximum value or minimum value what should we do right you know to get a maximum minimum in the quadratic function we have learned this right because by subtracting quadratic function from a function this will be also a function right it's really very nice okay and you have to identify this way that's how a student can feel this should be happening like this right then fx minus 2gx okay now then what is fx and what is gx then we can subtract fx minus 2gx first right okay no then you better write down this is something additional okay not at your answer sheet right I taught you because without that identification you cannot go hello I cannot remember the fx and gx right see fx and gx yeah okay then I will write if you want this data bar then you can have okay then erase this if you want to see it back then ask me. Right now I'm going to write down fx minus 2gx fx minus 2gx what is this fx 2x cube and a minus 1 x square b plus 3 x plus 1 minus 2 times gx x cube and c plus 1 x square a minus x plus 1 like this you have to subtract what is it 2x cube and 2x cube going to cancel now I'm going to cancel right going to cancel and this minus x square and what's happening are you O levels or A levels you are A levels no A levels right don't you have like O levels okay now let's tell me minus x square and going to come minus 2 times 1 my 2 2 is also there right minus 2 times 1 what is minus 2x square and this minus 1 square minus 3x square advanced students do like this okay and positive 3x and minus 2 into minus x what is this plus 2x and positive 3x what is that plus 5x you are errors plus 1 and minus 2 into 1 minus 2 plus 1 minus 2 result minus 1 this is the fx minus 2gx right to find the maximum or minimum value what is the strategy that you had always found completing square can we have a complete square for this why not we can this a quadratic equation right advanced level when you are making complete square you will have negative 3 outside and x square minus 5/3 plus 1/3 this come on and having this minus 3 x minus 5 over 6 square minus 25 over 36 plus 1 over 3. Completing square. X minus 5 over 6 square. Lamai, how to simplify this one? In the previous steps, additionally, if I write down 12 multiplication, now you can see common denominators and pick it. So what's the value coming? You know that 12 and plus 25, it is minus 13. And this is, what is it? Over 36. Are you okay with this? Right? You can identify because 12 times I got because of the 36 denominator, I have to simplify them. We must simplify. Therefore, the 12 and 25 is remaining negative 30, the common denominator 36. But it is not finished. It is not finished. Right? To finish it back, you have to multiply back with this coefficient you take out. Right? Therefore, you know, minus 3 times the bracket. Inside the bracket, we cannot come in, right? And minus getting plus. Getting plus. It's 13 over what is 12. How did I get 12? You are all levels not. You are levels. 3 and 36 getting cancelled. I don't go to show that step. 3 and 36 getting cancelled. You are getting 12. Right? Then tell me the max value, max point. So what's the max point? Max point and max value. To get the max point, it is 5 over 6, 13 over 12. Right? Right? This is the function, right? You know. Right? So max value, the maximum we give to the negative 3. Then because I didn't mention that max or minimum, you know the reason for having max, this could have been otherwise minimum, no? Without getting minimum, why did I get maximum? Because at the beginning itself, x square term is what? X square term is negative, right? When the x square term is negative, this should have been there, but maximum, you know it theoretical, right? Therefore, max value is like this. That you can write down, you can make the sketch, right? 5 over 6, like this. Therefore, fx minus 2gx, right? Max is 13 over 12. Therefore, fx minus 2gx, right, less than or equal 13 over 12. That is how we must write a maximum. Lamai, how many marks? In 2021, 2 days before. 150 marks, Lamai. 150 marks. If you want to show it back, then ask me, okay? Then I will scroll down. The thing is complete square. Thing is how we can identify. Okay, now let's go for a trigonometry problem. Hi, Laman.
Sir,
Yes.
sir, may antimally would lihat baru antimally.
We don't expect you to draw sketches of graphs, right? If we have a theoretically this knowledge, then without drawing a graph, without making a max point, then at once we can write down this step, right?
Hi, sir. Thank you.
Okay. Right. Let's see the next one. Part A of trigonometry problem. Right. Okay. Lamai, write down cos A plus B and cos A minus B in terms of cos A cos B sin A sin B. Right. What a question, Lamai. What a question, right? Then easily we can make it, right? Then you know cos A plus B. You write it. Cos A plus B. What's the rhythm? Cos sin sin. Cos A cos B. Right? Sin sin. I have strictly told all the students, at least you must have the formula in the trigonometry. Without that, we cannot explain anything. Now, this is a beginning, then you can collect the marks by means of the formula concept. It's not a problem, right? That's why I always ask you to follow my advices, right? I make 100%, right? You know that responsibility, right? With this responsibility, I tell you everything. Cos A minus B. Now, I cos A minus B. What is that? Cos A minus B. It's also cos sin sin, but the minus become plus become minus. That is all what happening. Cos A cos B plus sin A sin B. I think for the exam, 5 marks, there will be 10 marks now. For writing formula, then 5 marks, then 10 marks. Right? Okay. The 150 marks we have to collect, right? Okay. Now we have to write down, we have to find. So that cos C plus cos B, right? Cos C plus cos B, 2 cos C plus B, and right, that's the theoretical, right? And deduce that cos C minus B, also right. Okay, fine. Then how to get it? Right. Lamai. How to get it? Cos C plus D, cos C minus D. The formula. Then you better add them, Lamai. Right? Then if this is the connection number 1. Connection number 1. If this connection number 2, you can write down, right? 1 plus 2. If you get 1 plus 2, what's happening? Sin A, sin B, sin A, sin B cancel. Then this is cos A plus B, cos A minus B, cos A minus B. Now you know that it is 2 cos A cos B. Because getting cancelled, sin A, sin B cancel. There are 2 icons of cos A cos B, cos A cos B. There are 2 icons of cos A cos B. Right. This is the connection on 3. Now there should be cos C plus cos D. No? To have cos C and D, then you must additionally write down what C and D. Let C equal A plus B, B equal A minus B. Right? Get it? And now we can write down what A and B. Right? To find the A, simultaneous equation, you know, plus B minus B cancel, double A will be C plus B. Therefore, then you can write, right, if you add them together, what's up? Therefore, C plus D equal double A. What is A? A is the C plus D over 2. Then it's happening if you add them. We subtract them, right? Then you can subtract this side. Subtract or addition. This is happening. If you subtract this time, right, you know, A to A cancel. Because of the negative signs, negative getting positive, there will be C minus D double B. We have done this in theory parts, okay? Double B. Then what is the B? B is the C minus D over. Now in equation number 3, we can substitute, right? A plus B as C, A minus B as B, that's why we got also, right? And A is C plus B over 2, B is C minus B over 2. Now you are getting the connection number 1. And similarly, we can find C minus B. In 3, okay, what's happening? In 3, we can write cos, what is A plus B? A plus B is the C. And cos, what is A minus B? It is the B. Equal to cos, what is A is the C plus B. Over 2. And cos C minus D over 2. Right? Right, are you okay? Then I don't go to show that the second connection, right? Because time is going, right? Within 5 minutes we have to complete this, and we have to then find that cos C minus cos D, there will be minus 2 sin C plus D over 2 and sin C minus D over 2. Then you have to, right, subtract the 1 and 2 together, you can find it. By subtracting 1 and 2 together, it's coming. Right? Then cos C minus cos D is like that. Right? Okay, you can prove it alone. Okay? I don't go to do that because of the time. Right? Now we can go to the problem. This is theoretical. That's why in theory class even I have done this. Right. This remaining part, solve the equation, right? Okay. Now. This one. Right. So the equation cos 9x plus cos 7x cos 9x plus cos 7x plus cot x cos 9x minus cos 7x equals 0. Right. Now I no need to use a previous equation by looking at them because you must know them now. Right. They shouldn't have asked now. Yes, for exam, right? We don't admit this kind of problems in previously. You must have this knowledge, right, on your body, right? Because you know cos 9x, cos 7x, cos addition, and cos subtraction. You know what's happening, right? You can also use the previous formula. That's why they have guided that, but no need. Cos addition, it's 2 cos, 2 cos, and cot x, right? And what is the cos subtraction? You know what's happened for the cos subtraction? It is minus 2 sin. Why have I left some spaces? Spaces for, you know, sum of the angle divided by 2, subtraction of the angle divided by 2. Sum of the angle divided by 2, subtraction of the angle divided by 2. You do that. The sum of the angle 16x divided by 2, 8x. The subtraction of the angle 9x, 7x, 2x, but divided by 2x. And this one again, and sum of the angle 16x divided by 2, 8x. The subtraction of the angle 2x, 9x and 7x, 2x divided by 2x. Right? And now what's happened? Due to this negative sign, right, we can get this connection to other side. Two cos 8x cos x equal minus 2. There was cot x, right? Minus 2. May I write with the cot x. Minus cot x, then 2 sin 8x. The minus means, sorry, because of we got to the other side, we cannot write the minus again. We got this due to the minus and sin x. Are you okay now? Okay, now 2 and 2 getting cancelled. I'm going to divide both sides by what? Right? Sin 8x, sin x. I'm going to divide by what is cos 8x, cos 6. What can chance now? We can do that. And what is coming? One equal cot x and tan 8x and tan x. You know, cot x and tan x. If you know this product is 1, then we can remain with tan 8x. I got 10 divided. Cot x and tan x is 1. Otherwise, we can write further cot x as 1 over tan x and get it cancel. Whatever it is okay, and product is also 1, right? And what is your final answer before the answer? 1 equal tan 8x. Now you have to put general solution for this. Therefore, tan 8x equal 1. Tan 8x equal tan, what is that? 1. Where should we have 1 for the tan connection? Tan 5 over 4. tan 45. Then what's the general solution of tan? Tan theta equal tan alpha. It is theta equal n phi plus alpha. Can you remember? Therefore, this theta is not 8x equal n phi plus phi over. What is x? X equal n phi over 8 plus phi over 32, right? Where n equals 0, 1, 2, blah, blah, right? Integers, right? The answer, right? And are you okay? Right. In the usual notation, state and prove the cosine rule for a triangle ABC. Right, we will state because we need it, but I now don't go to discuss the proving of cosine rule because it's a theoretical part. We can do that for an acute angle triangle, and it will take a lot of time. That's why it will too long. Then for a right angle triangle and as well as obtuse angle triangle, we have to prove. When we go to prove, right, it is too long, right? But somehow, if the question is asked like this, then you have to do that, right? Okay, but it's a little bit theoretical. Then, but you can state the usual notation. In the usual notation, we have to state the cosine rule, right? The money. Then you will write down the money. There was a type of the triangle, right? We can draw. If the name ABC, right? You know the angles are simply. Sorry, the distance are simple. Angles are right. Now tell me, capital A, capital B, capital C, right? And distances are right opposite distance. B to opposite A, sorry, B to opposite B, C to opposite C, A to opposite A. Right, you know it. Right now, spend the cosine rule. Then we can write down cos A. Right, otherwise cos B. Cos B කියලා මම ලියන්න. reason එකයි cos B ලියන්නේ. මේ question එක මම නිකන් capture කරනවා මෙතන sin 2B එක. ඉතින් මම ඒක B එකෙන්ම ලියනවා. Right, I'm going to write down with in terms of B. What is cos B? එහෙමම compulsory නෑ cos A. Okay, what is cos B? We can write down cos B. How we can write it? Then you know the two sides, right, adjacent to the angle B is written first, right? Then are written first like A square and C square, and side opposite to B is subtracted, and we have divided by the first two letters of two ways. This is the right cos B. Right, few marks we can collect from this. Okay, this is also given. Let x equal to n phi plus phi over 2. By means of this, x is never equal to if n equal 0, this will be 5 over 2. N is not equal to 5 over 2, right? It is 5 and 3 5 over 2, right? It is given the condition, but we don't want to prove because it's late, no, right? But if we want to get a final answer, then there will be a little bit helpful sometime, but we don't know whether it's so useful for this problem. Then until we do that, we cannot tell. Okay, now show that sine 2x equal to 2 tan x and 1 plus tan square x. Okay, now how to show that answer, right? You know, theoretically, what's the method? Sine 2x. Then if I write down sine 2, what sine 2x? Sine 2x, 2 sine x, cos x. 5 marks for this, 5 marks, 5 marks. But we have to prove it. Now, to prove it, 2 sine x, cos x, right? You know, there's 1 below. How to prove it? Instead of 1, what should be right? In parametric form, we have done this. What is being written instead of 1? Sine square plus cos square x. Right? Theoretical. Theory balan kiya කෙනෙකුට ගොඩ යන්න ගන්න දීලා. Then we have to divide both sides by cos square x. 2 sin x cos x. You can divide by cos square x. Right? Sin square x cos square x. Okay, write down. What's the answer? Two. Can you see it? Okay, can you see it? 2. Then cos and cos cancel. 2 tan x. Then tan square x plus 1 sin 2x. Sin 2x, right? 2 tan x, 1 plus tan square x. You know this formula, right? Right? No need to show this, we know it, right? But we prove it. But there are few marks we can correct, not few marks actually. Then for writing formula 5 marks, and writing this formula there will be no more 5 marks, and by dividing cos square x there will be more 5 marks, and to final answer there will be 4 5 marks. About 20 or 25 marks will be there, right? Because 150 is the whole correction. Right? Okay. Now what is the question? The answer, right? Then you know the formula and we can do, right? In a triangle, you can read it. In a triangle ABC, it is given that AB 20, BC 10, and sine 2B 24 over 25. Everything is given, and this is question, so that there are 2 distinct such triangles, right? And the length of AC for each. Okay, right. Then if there are 2 such triangles, right, because of sine 2B, right, there is given sine 2B, no, right, we must have 2 B values if there are 2 angles. Otherwise, we cannot have 2 triangles. If there are 2 triangles or 3 triangles, then if you want to show that if there are 3 triangles, how should we prove? Now, definitely there should be 3 angles for the B. But this time for the 2 triangles, so there should have been two values for the b. Right? Okay, that's what we had to approach because it is given. We have to show that there are two distinct such triangles. Distinct means different triangles. Okay, now how to prove it? We can prove it. Wait. I'll erase these cases, right? Not it. Okay, now let's draw this diagram. For a triangle, we know ABC, right? ABC. AB is 20 cm and BC 10 cm. There's a B inside there because this is asked about B, no? But sine to be given, sine to be given 24 over 20. Right. Lamai, now to show that there are two such triangles, I must have two B values. To have two B values, having this sine 2b, I cannot get this. Lamai, instead of sine 2b, we have given a hint. The sine 2x. The 2x is given in terms of x. Then now sine 2b you must write in terms of b. Then how can we write 2 tan b 1 plus tan square b equal to 24 over 25. Apply it. Now there will be a quadratic equation to have the tan square b. For tan b, there will be probably two values, right? Then we can prove there are two such triangles because of there are two b values. Come on. You find it. If you don't find at the exam, then you can now find it. And AC distance also we have to find out. This is the question. AC distance we have to find. Before we go to find AC distance, right? We have to do it. Right, Aman? Then get your cross multiplication. 50 tan b equal 24 plus 24 tan square b. You multiply. Cross multiplication. So 50 tan b, okay? Now you know. Like what's happening? You can divide by 2. 25 tan b equal 12 plus 12 tan square b. Lamai 0 equal 12 tan square b minus 25 tan b right plus 12 plus 2 right and 0 equal right factorize this one right. We can write down 4 tan b 3 tan b 3 tan b, that will be the 12 tan b. But until you make the 25 12, you know 4 times 9 4 times 3. Therefore 4 and 3 we can write and minus minus. minus 9 tan B, and minus 16 tan B, minus 25 tan B. Tan B equal 3 over 4, tan B equal 4 over 3. Here, there are two distinct triangles here. Therefore, there are two distinct triangles. As B has two values. As B has two angles or two magnitudes or two values only. Two values, two magnitudes, two angles only. Now tan B is 3 over 4 or 4 over 3, right? There are two instances. Well, how to find this one? With respect to this one, look at this. We have to find the value of AC. AC where? How to find the AC distance? AC distance. Right, to find the AC, that's why they have asked us from the beginning, from the cos rule, you know. To find the cos rule, then AC is, we can write as cos B. Cos B equal, what is that? That was I have written 20 square. Look at this board, huh? Cos B, because B, and there are two sides aside, right? Adjacent side. 20 square and 10 square. You know, subtract the opposite square. It is AC square over 2 times, right? 20 times 10. This first two terms are written below that 2 times. So cos B. But the problem is then you have to find out cos B. Now when tan B is 3 over 4, there will be cos B value. When tan B is 4 over 3, there will be cos B values. In order to them two cases, there will be two values for AC. Now answer will be complete. Write down. When tan B equal 3 over 4, just write the triangle, draw triangle. We will make this as 1. Right? When tan B equal 3 over 4. This is 5. What's that? Then what is the cos B? Cos B is 4 over 5. 4 over 5, 200 and 100. AC square. This is, yes, 400. Am I find AC?
Sir,
Yes.
20 square and it should be 400.
Yeah. 400. Very good. 400. Otherwise, different analysis. Yes. Very good. 400. And 4 over 5 equal 500 AC is power 400. 4 into 400. 2500 minus 5 AC square. And 5 AC square equal 900. Is it something? AC is like 30 over root 5. AC is, you multiply by root 5. I don't show you that because you are math students. 6 root 5 centimeters. This is one of the answers. There are two occasions, right? Now, same thing should be happen for the when tan be equal to reciprocal of that. Now 4 over 3. We now previously got 3 over 4. When tan be equal 4 over 3, there will be another particular value. You find it. Lamai, you will feel papers are okay, then you can do, right? Remember. But nowadays I am discussing past papers like 2002, 3, 4, 5, 6. They are a little bit tough, right? Then it's safe to be like that. This paper is also a little bit tough. This toughness is happening due to the mentality of the students now faced for the exam under COVID situation. Due to the pandemic situation, then we as teachers, no teachers expect like the students will be complete the answers like how previous year students wrote the answers, right? That's why we compare that the paper is a little bit too long and hard. But this time we don't tell that because of the COVID. Without COVID, this should be the standard paper ongoing. We know that, right? According to the last 2 years and 3 years, then this is the nature. Right now, come on. Right again, you know the possible, right? You have like when tan be equal 4 over 3. The cos B is now 3 over 5 equal. You can remember this was 500 minus AC square. You can remember this was 400 or something, no? Right? You do that. This is 1200. And 2500 pi AC square. Pi AC square is 1300 or something. AC is 5 times 2, 36. This is 4 times 65. 2 root 65 centimeters. Right? 2 root 60. That's my final question. Right. PD. Right. The question is sine inverse 1 plus e to the power minus 2x bracket to the power half. It is also minus half, right? E plus tan inverse ex tan inverse 2, right? Then how can you do this problem? Then your target is solve the question, right? We have to solve. The what do you mean by solving? What do you having, right? What is your answer having? So by solving the value for a ex or value for x, what's the target? That's what I want, right? Or what are you getting? By solving an equation, you are getting ex or x. X is a constant, right? Right. Then we have get it from x. Okay, how can we get it from x? Once we have ex, because this is going through ex now, then we must know this, right? If there's ex equal to, how can we get it from this? Right? So basically, we must write down, right? For the both side, we can have logarithm Lg, right? Sorry, len. For the both side, len. We can have len ex equal len 2. You must remember len is the logarithm e to the base ex len 2, right? Therefore this will be x, right? Because you know this is 1, therefore x equal len. Therefore if we have something, then what is the inverse function of the exponential is the len. Then remember, once you have ex equal 3, no need to go in this way. If you want, then okay. But if you have, remember this, definitely you can write y equals x is len 3. This is your answer. Now, note down this, right? If you want that, then how to write? How to find x? Then if there's something e to the power x, then we can write your answer in terms of len. Come on, hurry up now, we have to write down. And is there something like wait, e to the power, right, like minus 2x equal 7, or write it minus 2x equal len 7. Len 7. Right, now we can find x equal, right, minus half len. And x equal len to the power 7 minus half. Right? And we can simplify and have it x equal, right, len 1 to the power square root 7. because you know power half is the root 7, but negative indexes we can write as positive. Write down solve. Directly we can write length for the EX. Okay, Lama, let's see how to do this problem. Right. Look at this. Lama, there are several ways to think, right? Then we better have this tan inverse x to other side, and we can do tan. Then also we can further convert this into tan no. Then we can do, right? Otherwise, we can write on because by then first I should remind you, I think. By means of tan inverse EX or tan inverse 2, what is implementing? Is that a value or is that an angle or what is that? Inverse means, right? I have told you that they are the angles. Therefore, we can indicate below them. These are alpha, beta equal to gamma, like that. These are angle, like 35 degree plus 15 degree equals 60. This is a connection having angles, right? This is sine inverse are the angles, tan inverse angle. It's a connection between angle, right? That's right. Okay, but however, because of this tan inverse connection, I would like to convert this angle in terms of tan inverse. Can I write the angle in to indicate an angle? Right? Look at this. I just help you. If this is alpha, if you have 3, 4, 5, for this alpha, then we will write any connection, the same alpha. Then what are the types of method that we can write to look at this? Then if I write down sine alpha, then before we go to discuss this one, we have to remember this. Sine alpha is you are writing 3 over 5. Cos alpha is you are writing 4 over 5. And tan alpha you are writing, tan alpha you can write. Look at this. Tan alpha you are writing 3 over 4. Okay. Now, if you write down what is alpha, right? Sometimes the alpha will be 3 over 5. Sometimes alpha will be cos inverse 4 over 5. Sometimes alpha will be tan inverse 3 over 4. Therefore, I pointed out that, right, due to that case, right, same magnitude alpha angle we can write in 3 ways. Either sine inverse 3 over 5 equal to cos inverse 4 over 5 and also tan inverse 3 over 4. Right? Can you capture this? Therefore, same angle denoted by in terms of sine inverse sometimes, in terms of cos inverse sometimes, in terms of tan inverse or cosec, sec also there, right? But generally we can write sine cos tan. The same angle, otherwise same 32 degrees, I don't know. Same 5 over 4 degrees, I don't know, right? Same 3, 5 over 4 degrees, right? Whatever, right? This is the negative angle like this, okay, right? But whatever they are, now my angles we can denote it by, right, 3 ways mainly and 6 ways definitely, right? Okay, but then basically sine inverse, cos inverse, tan inverse, right? Due to that case, now I ask from you, listen me, right? Lamai, looking at this equation, right? We can write down this sine inverse connection in terms of tan inverse. Why am I thinking like that? Because right hand side you have tan inverse, that's very beneficial if you have tan inverse both sides. Are you okay? Then may I convert this into tan inverse? Okay. Or otherwise, other thing is, then because of sine inverse there, I can bring this tan inverse x to other side and both side, then the right hand side there will be tan inverse. So I can write down in terms of sine inverse for the whole side, right hand side, and cancel the sine inverse case, and we can solve. This is the second concept. I think first concept is okay, right? The first concept, then I can write down this one, right? In terms of tan inverse, right? Therefore, then what is that? Let sine inverse 1 plus e to the power minus 2x to the power minus half equal alpha. Therefore, sine inverse other side, it will be sine alpha. 1 plus e to the power minus 2x to the power minus half, right, equals sine alpha. To get the tan inverse connection, I must have a triangle, but I must have a ratio. Wait. Therefore, I will just make a conversion. This is insidely e to the power 2x and minus half sine alpha. Right, right on with me. I'm finding tan alpha. Right, and I will get the reciprocal, simplification. It is totally e2x plus 1 over e2x, right, minus half, right, and sine alpha. Now what's happening? Now you can write down what is that? Reciprocal. Therefore, sine alpha equal e to the power 2x e2x plus 1 power half. Now I now get it from the negative symbol. Instead of this negative mark, I now just got a positive mark, getting the reciprocal. And not only that, Lamai, what is the power half of the e2x? It is written further e2x, right? Power half over e2x plus 1 square root. Do you agree with this? I want to ask you. Then we can cancel between this 2 and 2. It is, look at the answer. Ex e2x plus 1 square root. This is the sine alpha. Then have a triangle and get tan alpha. Alpha, right, ex e2x plus 1 square root, right? We have to find this distance, let's say m. Right now, and how to find the m? You write m square plus ex square equal to e2x plus 1 square root, right, whole bracket square. It is m square plus e2x, because power of power, you know, power of power, this is being e to the power 2x, and the square root cancel, e to the power 2x plus 1 e to the power 2x, now getting cancelled. Wow. Cancel. M is, what is M? Now M is 1. Right? Now we can write down 1 for this. M is 1. Now what is then tan L? What is a tan L? Right? මේගාන හරි hard ඔයගලන්ට මේ ආව question මම මේක තමයි කියන්නේ. EX වලින් ගණන් හදලා නැතිලා අපිට මේක කවදාවත් කරන්න බෑ. Right? Tan alpha then EX over 1. Then tan alpha is right EX over 1. Then what is alpha? Therefore, what is alpha? Tan inverse EX. Wow. Alpha is tan inverse EX. Same alpha, right? Same angle. I now have written in terms of tan, right? Alpha, not sine. But your answer question was right. Therefore, we can write down what is the question? Sine inverse, right? The something to the power minus half plus tan inverse. This one was your answer. Tan inverse EX and equal tan inverse 2. You had this. Now, instead of this one, we can write down what? We can write down tan inverse X. Because the same alpha, then tan inverse EX, tan inverse 2. There are more methods, okay? This is one of the, right? I pointed out there, okay? And also I will explain in different ways, so if you want, right? I don't go to explain this method is longer, shorter, right? Because I just a method, right? I got it. Right now, and this is tan inverse X plus X over 1 minus, sorry, not X plus X. Tan inverse. This is EX, no? EX, right? Therefore, EX plus EX 1 minus EX EX. Tan inverse 2. Tan now getting X. Right? Now, how did I get this one? You know, tan inverse X plus tan inverse Y. We can write it tan inverse X plus Y 1 minus XY. Can you remember? This is the formula we applied. Tan inverse. Now, if you don't know this formula, no use of being in the syllabus. This is your big weak point, right? You are never having a or B pass, even you don't have this kind of connection, right? Because theoretically, you must have seen this, right? Connection, because these are identities you know, these are not mathematical problems, right? When I, right, at once applied over there, if you are difficult to remember this formula, this is your weak point, right? The not solving problem is not your weak point, it's gradually, right, increasing your knowledge. But to increase, so accelerate your solving problem knowledge, you must have the basic concept, otherwise you cannot go along, right? Then you see, now what's the answer? EX, this is 2EX, right? 1 minus e to the power 2x, because if the base are same, x and x getting added, 2x, right, equal to 2. Both sides 2 and 2 getting cancelled, EX equal 1 minus e to the power 2x. What a question is this now, right? Therefore, we can write down e to the power 2x plus EX minus 1 equals 0. E to the power x square plus EX minus 1 equals 0. This is like a quadratic equation of EX. Right? It's a quadratic equation of EX. Now we got this, right? by means of other method, you don't have a quadratic equation and you will get the same answer. Okay, right? I just did this method, right? And also you can follow the other way that I earlier mentioned. Okay, now look at this one, right? So this one is a quadratic form in terms of ex. Now x is the ex, right? It's running in terms of ex. Now therefore ex is, right, minus b plus or minus b square minus 4ac over 2a is the concept to solve this, because this doesn't have factors, right? Because a, b, c, a is 1, b is 1, c is minus 1. You substitute, then you will have an answer for ex. Have it. The ex minus b is 1 plus or minus 1 square minus 4, a is 1, c is minus over 2 times 1. Ex equal minus 1 plus or minus root 5 over 2. Ex is positive, right? Therefore, what is the ex? Ex is minus 1 plus root 5 over 2. Root 5 minus 1 over 2, same as. If ex equal, right, root 5, you know, root 5 minus 1 over 2, what is x then? This is root 5 whole thing or not? What is x then? X is ln root 5 minus 1 over 2. Right? They were tripled down at this problem, right? It's a yoker. At the exam, this was a yoker problem, right? That due to this problem only, right, of the trigonometry. In this trigonometry, this is the hard one, right? This is the hard one, really hard, because of I don't believe that a lot of students are not going to solve problems at their paper discussions and model paper discussion. They are not dealing with ex terms. That's the problem, and they don't go to solve ex equation. And in my case, even I also didn't conduct ex part due to that matter, because I told you, can you remember at the beginning of the type of equation, right? I told you trigonometry, even the ex condition is there, right? Logarithm and ex, but exponential equation, right? But this is not even in the exponential equation. Is more than that, exponential mixed with the tan inverse equation. That's the problem that we have, right? Right? Okay, don't worry about that. Okay, what is the other way that we can do this problem? What's the other way? Right? Other way is the right. Then we will go back to the problem again. Right? Did you write this? Okay. Should I show you the upper part? So scroll down. Right? The same problem. We can solve this, getting this tan inverse x to other side. And also we can deal with the sine inverse concept, because alpha and beta, for both sides we can have sine alpha plus beta, right? And we can solve it, right? And because if we get alpha and beta for this, then I can really get this sine inverse concept for the both sides, and we will be able to solve this equation, right? This is the other way. Then I don't go to discuss with it. Then ex is the same concept. Then you can follow, right? Then sine inverse will be now cancelled, because of if you get the sine inverse for the other side, right? Then no need to simplify this one, but sometime instead, then you will have to get the reciprocal and LCM and do that as I did in the previous problem, I think so. And but this won't be have, I mean, but quadratic equation. At once you will get ex, but there's a predictable simplification like it's square root of e double x. then e to the power 2x, then ex will be coming for that, and you are getting the answer. Right, the same way. Okay, but only thing is, I think no quantification come when you get this one to the side and cancelling sign inverse to both sides. We can do this. Okay, okay, you just follow as a homework this one because I don't go to discuss this method, right, because it's too long. Right, now the time is over. That's why otherwise I should have discussed. This is now 6:30. Right, I promised to do this until 6. Right, now time is over. Okay, now we are going to wind up. Right, then the next day we will meet with another 2 questions, algebra and trigonometry. Okay, Lamai. Then, is there any question before we stop there? One question අපිට කරන්න තියෙන්නේ කොහොමත් අපි ටයිම් එක පැය භාගය වගේ තමයි කඩාගෙන යන්නේ. පැය භාගය විනාඩි 20ක් වගේ යන්නේ. ඉතින් අතන ටයිම් මැනේජ්මන්ට් එක මම අන්තිමට කියලා දෙනවා. දැන් ටයිම් මැනේජ් කරන්න හිතන්න යන්න එපා. right? මොකද පැය 3යි දෙන්නේ. පැය 3ක් කියන්නේ පැය භාගය 6ක් නේ. ඒකට පැය භාගය 5ක් තමයි ගණන් පහර දෙන්නේ. ගණන් පාර පැය භාගය 5යි ගණන් අර 10ක් තියෙනවා පිටිපස්ස 10. ඒකට පැය භාගය තමයි කඩා ගන්න. සාමාන්‍යයෙන් කඩා ගන්න එහෙමයි. නමුත් මගේ ටාගට් එක පැය භාගය ගන්න නෙමෙයි විනාඩි 20න් ක්වෙස්චන් එකක් ඉවර කරන්න ඕන කියන එකයි මගේ ටාගට් එකේ තියෙන්නේ. ඒ විනාඩි 20න් ඉවර කරන්න ප්‍රැක්ටිස් කරන්න නැතුව එකපාරට කරන්නේ. හරි. විනාඩි 20න් ඉවර කරගත්තොත් එතකොට අර ඉතුරු වෙනවා පැය විනාඩි 10ක 5ක්. හරි. එතකොට කෙටි ප්‍රශ්න හොඳට කරලා යයි. සහ සමහර දිග්ගැස් යන මේ වගේ ප්‍රශ්න වලදී ඒවා යූස්ෆුල් වෙයි. විනාඩි 20කට පුරුදු වෙනවා. දැන් උඩ පළවෙනි ක්වෙස්චන් එක විනාඩි 20න් කොහොමද කියලා ඒක ඔයාලට කරන්න බෑ. ඔයාලා ප්‍රැක්ටිස් කරන්න. ඔයාලා ට්‍රිගොනොමෙට්‍රික් ක්වෙස්චන් එක මේක නැතුව අනිත් ඔක්කොම විනාඩි 10න් විනාඩි 5න් කරලා. හැබැයි මේ කැලල කරන්න ගියාම ඇදෙන්නේ. මේකට යනවා විනාඩි 15ක්. අනිවාර්යෙන් ඇදෙන්නේ. අන්න මේකට ඇදෙන එක එහෙම තමයි මේ ක්වෙස්චන් එක අර ඒ වාසිය ගන්න ඕන අනිත් ඒවා වලින් කෙටි. හරි. ඕකේ එහෙනම් අපි මෙතන ඉවර කරමු නේ. right. හරි ළමයි. කැමරාව on කරලා හිටනකොට thanks. right. God bless you.
God